All right. Ammonia. I'm gonna jump to this. Okay. Dicarbon tetrahydride and oxygen. Make carbon dioxide and water. Go.
I like it when you have
Yeah, the prefix is ours. Alright, yeah, right. We're done. Yes.
Dicarbon tetrahydride.
By charges, you mean?
Yeah.
That's why they give you the prefixes to make you like force you to be like this. Dicarbon. C2.
If you make a table, it's actually really useful.
Nice one. Dan, give me the nuts.
I really
Oh, why do you do this?
Wait, are you allowed to change it?
Is this
I
correct?
wrote this on notes. Oxygen.
That's so totally me.
Oh.
This one's a little gentler because they're giving us prefixes. We don't have to do as much procedure X work here.
Nice.
Some of them they're gonna give you the softball. Some of them you're gonna have to like work through from the ionics. It just changes problem to problem.
Hey, was everything else in my equation correct?
Did said your equation's correct?
I don't know.
Well, we're gonna talk about it.
Correct, yeah.
Jamie, what do you got for dicarbon tetrahydride?
Probably
C2H4.
Correct. Again, these are covalent compounds. They're both nonmetals, so they give us the prefixes. We don't have to do procedure X type stuff. Okay? And oxygen, which comes in diatomic packages. That's one of the things we're sort of learning this week. Okay? Makes carbon dioxide down is CO2 and Wawa is H2O. Okay? Once you've got that,
I do.
think about balancing it for a sec.
All you have to do is add the 2 to the 1.
Hold on. We're gonna work through the road here. Like, big science show offs like you dominate all the time. Alright. So, Lily,
When did you start doing actual H's?
how many carbons do I have on my reactant side? Carbons. I have 2. So what do I have to do on my product side? Put a 2 where? In front of the what? Not the C. Say the CO2. Say the whole chemical. So you're like knowing that it's present. Something else. I don't even like the word shh. Listen, focus. I don't like add a 2 in front of the C because that's both those wrong. Adding, it's not adding, we're multiplying. And in front of the C is just one chemical. So say, I'm going to multiply the CO2 by 2. Gives you a better sense of what's going on in chemical. Okay. Elias, I have, what do I have to do for my hydrogens?
You have to put a 2 in front of H2O.
I'm going to put a 2 in front of H2O. Alright? That's going to go 2 times my water molecules, each of which has 2. 2 times 2 is going to get me up to 4. Yeah. And that is 4 because of the name of the molecule. Okay. Will, how many oxygens do I get from this molecule now?
That molecule is
4. How many oxygens do I get from this molecule?
2.
So how many oxygens do I have total on my product side?
6.
6. So what am I going to have to multiply by oxygen by to get there?
3.
The sum of the coefficients in this one is 8. The sum of the coefficient in this one is 8. 1, 3, 2, 2. Smile nod.
You have to add the 1 from.
Yeah, you have to include that in your number.
Dave, can we get the homework?
Yes.
Smile away, buddy.
Okay.
Smile away.
This type of reaction is a what reaction, by the way?
That's going to be one of those classic double replacements.
Nope.
I think combustion powder.
It's a combustion reaction if Johnny's ever seen one.
Ooh.
So this is a classic combustion. Hydrocarbon, oxygen, carbon dioxide, and water. They can expect you to know those products. All I'm telling you is it's tetracarbon decoxide it is burning. So that means it's going to react with oxygen. It's going to make carbon dioxide and water. Go. Very similar, different hydrocarbon. Very similar reaction to what we just did.
Yeah.
Different hydrocarbon. Go.
What's up?
I need homework.
Oh my god. Okay, so
CO2 and H2O. It always makes.
Here's the homework.
If it's a burning, if it's a combustion. Oh yeah, thank
Oh
you.
yeah, Jimmy,
Yes, please.
what's Deca?
It's 10.
Like decade.
What are these?
That's 100 years, guys.
Wait, but there's no age.
Yeah.
This is so mean.
It's like candy.
Wait, I thought it was
Am I
C.
sliding back and backsliding?
I thought it was C.
It depends on what type. Tetra means 4. So it's 4 carbons. Deca means 10.
Yeah, that's 210. Yeah.
Burn means what reacts with oxygen to make carbon dioxide and water.
But I thought it was.
Same goes to you.
Why is it?
Why is it hydrogen? Oh, you're right. That should be decahydride.
Okay.
My bad.
I was like, I don't understand where, what.
Yeah, sorry, my bad.
Okay.
Hydrocarbons are carbon and hydrogen. I just screwed that up.
So whenever it burns, it always oxygen.
Plus oxygen makes carbon dioxide and water.
Why is there an oxygen?
Why is oxygen? When anything burns, when a hydrocarbon burns, it reacts with the oxygen in the air. The products are always carbon dioxide and water. Okay, write this down.
I wrote it.
And then think about what you have to do to balance your carbons and hydrogens.
Why is there a plus?
There's
What?
water and there's whatever CO2 is.
These are right
Oh,
numbers.
I thought it was like a tiny plus.
Nope, that is not a charge plus. That is like and this plus this. This reacting with this.
Okay. And not the best person to cheat on. So I recommend.
Oh,
Wait, so what do you?
What if I got 13 but I needed to manipulate?
I don't know how to do this. That's a problem.
This is a tough one.
Yeah, what do you do?
Is it possible?
Is it like a solid number or is it?
Do you have to just keep going until you have like the huge number?
Do we have to multiply H2
Ah!
by 10?
Zach,
So-
I'm just
Oh,
on
by
oxygen
5?
right
O2 by 5?
now.
Yeah, I know. 'Cause
Not quite.
Wow.
Can we do they have to be whole numbers?
I can't get it.
Oh wait, shoot.
Oh, it would just be going up to 10, right? And then I'd have to fix hydrogen. I mean oxygen. Wait, what?
Wait, I got 9.
So wait, can I like, so
It's
there's
gonna be
10
like 20
hydrogens
hydrogen
on
or
the
something
reactant
like
side, and only 1, or 2 on the other side, so do you have to multiply that one by 5?
Yes.
And then oxygen is now, there's 5 oxygens.
Well, hold on. Look, as you said, he has balanced our hydrogens. He's balanced 5 times 10 to the 10. Jamie, balance my carbons. What do I have to multiply CO2 by? 4. So now let's do a count here. How many oxygens do I get from this molecule? 8. How many do I get from this molecule? 5. For a total of 13. So that says, do I then say like 13 halves or something over here? No, thank you. That's ugly looking. We don't want to have fractions. What can I do to get rid of that 1/2?
Multiply by 2.
Multiply everything by 2. Because if I do that, that's going to cancel out my fraction here. So my balanced chemical reaction is going to be, get a gold going on here for this champion one, 2 of these plus 13 of those makes 8 of these and 10 waters. Okay? Why did we do that? Again, because this was a fraction that it took to balance that, because this is O2 comes in packs of 2. I couldn't make 13 out of packs of 2, so I had to double everything so that my oxygens could balance as well. This is a big enough one that everybody should be making one of these reactants products tables, okay, to make sure that we've got it. Once we think we've got it balanced, we'll say carbon, hydrogen, oxygen. Okay? So, my carbon on the reactant side is 8. On the product side is 8. My hydrogens is 20 on the reactant side. This is 10 times 2, also at 20. Things are looking pretty good. How many oxygens do I have on my reactant side?
26.
13 times 2 is 26. Over here, I've got 8 times 2 is 16. I've got 10 times 1 is 10. That indeed adds up to 26. All right. Let's see. Oh, yeah. All right. Balance this and you can leave. Balance this. Show me this in your notebooks balanced, and I will give you your homework and send you on your way. Yeah, come on.
Are you gonna check it?
Check
Look
what?
at this and say, you got that balance? You understand this lesson? You're free to go.
Ammonia.
NH.
What's copper too? Is that like copper?
It has a charge.
Is that copper and then like a +2 charge?
Let's do it.
And copper 2.
So Dave, there's like a common, we just do a plus.
Say again? If there's a, like, and that's a plus.
Water,
Oh,
and nitrogen gas.
Yeah, all those are pluses.
Okay. Okay, so this can combine.
So decomposes into water,
No, it's just copper too.
nitrogen, yeah.
Copper.
For H2O, do we put liquid or aqueous?
The H2O is just liquid, but you don't have to write those states of matter.
And so, in copper metal, is that just Cu?
With a solid S.
Copper metal just Cu.
Yep.
So we have.
So Dave, is it CuO2?
Alright, we have enough copper.
Which one?
For the first one, for the reactant, would it be CuO2 or would it be CuO2?
Cu's got a +2.
Are you?
Oxygen gets what kind of charge, Lily?
Minus 2. Oh, so it should be CuO2.
Wait, so nitrogen gas is N2.
No. I don't.
No.
I think I did it.
Okay. That one's out. Now I have 3 oxygen.
Yep. I'll trade you that for your homework.
This would be 3 oxygen, 3 oxygen,
I like all your work. Sorry.
Okay, I think I did it.
Alright, I'm gonna check some views and those who want to check in.
Oh, wait, shoot, I'm stupid.
Any questions on that yet?
Yeah. Okay.
Got it, wait, Dave.
Is this what you got?
Finish this. Just got another 3 seconds fast one.
Alright, Dave.
I definitely did this one. I just forgot about what.
Since we're checking that.
That's an H3.
Ammonia.
Wait, Dave.
So I got
Wait, did you put
nitrogen.
Cu? I just
6 hydrogen.
Can't believe copper +2, oxygen +2.
Yeah, so
did
Cu.
you have Cu?
Cu.
Oh, is it +2?
Yes.
Learn.
Jay?
Did I turn on the light?
It's not gonna take me like 30 seconds.
Yeah.
Must be you or you.
What else?
Oh, Dave,
Like
I'll
fish
have
or
to
meals?
be class tomorrow.
You don't put it.
Any questions on that yet?
Yeah, it's just CU normal because it's negative 1 and negative 2 and 2. So it's just
This one?
1-to-1 ratio.
Yes.
They almost had it.
Okay, what's all? So
Ammonia is NH3. Copper 2 oxide is CuO. Makes water and nitrogen gas and copper metal. To balance these, I need 2 here and 3 here to get 6 hydrogens on both sides.
Got it.
That gives me 2 nitrogens, which is balance there. My problem is not my oxygens. I have 3 oxygens here, so there's 3 here.
Yes.
To balance the coppers, I need a.
Use 3 coppers on the side.
If you have your homework, I'll be happy to receive it.